Hi, I'm Chris Carriaga, and I'm going to be talking about a project developed alongside Mahesh Reddy for CMPT 985 at Simon Fraser University. Our project is on a computational and automated approach to data moshing. Now, surely you're asking yourself, what even is data moshing? Broadly, data moshing is the process of corrupting digital media, typically video, in order to generate a sort of glitchy effect. For this project, we focus on the typical use of the word. That is, to produce perplexing visual effects by altering the video compression process. For example, this effect can be seen in the popular music video Lamborghini High by A$AP Mob. This effect we just saw is actually quite difficult to achieve. Data moshing works by manipulating the data stored in compressed video. Video compression typically works by storing various types of frames. Some frames, called iframes, store the actual visual data and can be displayed on their own, while other frames, called B and P frames, only store predictive motion information to update the visual information in the iframes. To create data moshes, software is used to remove the iframes, causing P and B frames to be falsely applied to incorrect data. In order to forego the process involved in creating traditional data moshes, many have tried to replicate this effect using video editing software like Adobe After Effects. But these solutions are limited and sometimes only emulate the surface level appearance of data moshing without actually incorporating ideas from traditional data moshing. In contrast to other methods that create a data mosh effect based on the video compression process or editing plugins, our work makes use of optical flow to emulate the data moshing process while enabling more control and artistic freedom. Given a set of videos, our method estimates optical flow using off-the-shelf algorithms to synthesize the combined video where each transition has a data moshed effect, as seen in this example. To illustrate how our method works, consider two videos, A and B, that we would like to combine with the data mosh transition. We first compute optical flow for video B. This gives us a vector for each pixel that describes its motion on the image plane. We then take the last frame from video A and warp its pixels using the optical flow computed from video B. After warping the pixels of video A, new information entering the frame in video B will cause holes in the warped result. To address this, we additionally warp a binary mask that can be seen in the bottom row here to determine which pixels actually have visual information. For blank pixels, we simply fill them using the visual information from video B, giving us our final result. This is a simple algorithm that gives seamless transitions between clips while maintaining glitchy effects associated with traditional data moshing. By playing this video in reverse, we can achieve an effect where seemingly random pixels coalesce to perfectly generate the next scene. The only problem with this approach is that the video ordering in motion is now reversed. To address this, we first reverse the ordering of the videos we'd like to mosh. After that, we reverse the frames in each of the videos. From here, we can simply run our normal forward data moshing that was previously described. Now, by undoing the process of reversing the frames and clip ordering, we end up with a reversed mosh effect where each video is in the correct order with non-reversed motion. And here's how it looks. As I walk through and the camera pans, you can see that all of the pixels combine to create the first frame of the next clip in a seamless fashion. So now we'll show some examples of what can be created using the techniques we've discussed thus far. As we can see here, using only panning and zooming without any interesting motion yields slightly boring compositions. In this example, we have a sequence of panning clips. This is how they look before moshing. Here's how the video looks after combining the clips using the regular forward moshing technique. We found that a mixture of smooth camera movement and fast motion of video subjects makes for an interesting smearing effect. By running a scene detection algorithm on existing videos, we can easily create data moshes. Here's an example of a moshed skateboard montage. Here's another skateboarding edit, followed by the data moshed version. Another interesting application of our datamoshing effect is to create looping videos. Given a single video, we first reverse all of its frames. We then compute optical flow for each of the reversed frames. We use the optical flow to warp the original starting frame of the video using the reversed frames to fill in the holes. Finally, we reverse the warped output to retrieve the original ordering of the frames. If all goes well, we end up with a seamless result like this. Here's an example of using similar textures and panning to create a perfect loop. Here's an example where the optical flow estimation was imperfect, causing the final frame of the GIF to have glitchy artifacts left over. Still a cool effect nonetheless. In conclusion, we were able to develop a straightforward datamoshing effect that is inspired by traditional compression-based datamoshing. Rather than exactly emulating the behavior of traditional datamoshing, we aim to provide a similar effect that allows for more control. Users can alter the parameters of the optical flow algorithms, create reverse datamoshing effects, and generate seamless looping GIFs. We hope this project will provide a useful tool for video editors and social media content creators to create mesmerizing videos. We have included links to the GitHub page for the project, as well as a YouTube playlist with more datamoshes, both available in the description. Thanks for watching.